Derivation of Simpsons rule using Newton-Cote's formula. We will derive Simpsons rule 1 by 3 and 3 by 8, both of the rules of Simpsons using Newton-Cote's formula. The Newton-Cote's formula is as follows. Integration of from a to b f of x dx is equals to nh summation I is equals to 0 to n yi ci n. Again, where cin is equals to 1 upon n integration from 0 to n liu du. Here liu is equals to u minus u0 into u minus u1, so on up to u minus u I minus 1 into u minus u I plus 1 divided by ui minus u0 into ui minus u1, so on up to ui minus ui plus 1. Note that we didn't include here u minus ui term. This is here liu is Lagrange's interpolation formula. Now let's derive 1 by 3rd rule. Simpson's 1 by 3rd rule. Here we will put n is equals to 2. In Newton-Cote's formula we described that. So putting n is equals to 2 in that formula, integration of f of x dx from a to a plus 2h is equals to 2h summation I is equals to 0 to 2 yi ci 2. Here we put n is equals to 2, that's why it becomes ci 2. So expanding this, we got integration a f of x dx from a to a plus 2h is equals to 2h y0 c02 plus y1 c12 plus y2 c22. Let's this equation 1. Here c02 by formula, where cin is equals to 1 by n integration of liu du 0 to n. So putting n is equals to 2 in this formula, we get c02 is equals to 1 by 2 integration l0u du 0 to 2. Now we will find l0u. L0u is equals to u minus 1, u minus 2 divided by 0 minus 1, 0 minus 2. Here we can note that we didn't include the term 0, u minus 0. And in denominator we subtract n from 0. That is 1 and 2 from 0. We subtract I from 0. Okay. Now c02 in this way becomes 1 by 2 integration from 0 to 2 u minus 1 u minus 2 divided by 0 minus 1 0 minus 2 du. This becomes c02 is equals to 1 by 2 integration 0 to 2 u minus 1 u minus 2 divided by 0 minus 1 0 minus 2 du. Solving this whole, we get 1 by 2 integration 0 to 2 u square minus 3u plus 2 divided by 2 du. Finally this becomes 1 by 2 into 2, taking this 2 outside, 1 by 2 into 2 0 to 2 u square minus 3u plus 2 du integration. Integrating this term, this particular term, we get u cube by 3 minus 3 square 3u square by 2 plus 2u from 0 to 2. After solving this whole equation, here we can see that we get 1 by 24, 16 minus 36 plus 24. Finally c02 is equals to 1 by 6. Let's say this as equation 1.1. Coming on to next, we get c12. We will find c12. c12 is equals to, again putting in the same formula, 1 by 2 integration 0 to 2 liu du. So c12 is will be equal to 1 by 2 integration from 0 to 2 l1 u du. L1 is u minus 0 u minus 2 upon 1 minus 0 into 1 minus 2 du. So on solving this particular equation, we get c12 is equals to 1 by 2 integration 0 to 2 u square minus 2u divided by minus 1 du. So finally Solving this by integrating, we get c1 2 is equals to minus 1 by 2 u cube by 3 minus u square 0 to 2. So finally we get c1 2 as 2 by 3. Let's say this as equation 1.2. In the similar way, we will find c2 2. Putting in the same formula and integrating the same term, again we get c2 2 will be equal to 1 by 6. Let's say this as equation 1.3. Again, from equation 1.1 we get c02 is equals to 1 by 6. From equation 1.2 we get c12 is equals to 2 by 3. And from equation 1.3 we get c22 is equals to 1 by 6. Putting all these three terms in the formula, we saw a integration of f of x dx from a to a plus 2h is equals to nh summation I is equals to 0 to n y I c I n. So finally, putting these three terms in the formula, we get integration of f of x dx is equals to 2h y0 1 by 6 plus y1 2 by 3 plus y2 1 by 6. So finally we get h by 3 y0 plus 4y1 plus y2. So integration of f of x dx from a to a plus 2h is equals to h by 3 y0 plus 4y1 plus y2. This is Simpson's 1/3 rule. So we have derived Simpson's 1/3 rule from Newton-Cote's formula. Coming on to next, we will derive Simpson's 3 by 8th rule from the same Newton-Cote's formula. We have seen Newton-Cote's formula, which was integration of f of x dx from a to a plus 3h this time. We will put n is equals to 3 to derive Simpson's 3 by 8 rule. So will be equal to 3h summation I is equals to 0 to 3 y I c I 3. So integration of f of x dx will be equal to 3h y0 c0 3 plus y1 c1 3 plus y2 c2 3 plus y3 c3 3. Let's say this equation as equation number 1, where ci3 will be equal to 1 by n integration liu du 0 to 3. Hence, let's find ci3. First of all, c03, putting in the same formula and getting the value of l0u, we get 1 by 3 integration of l1u du, which is this, from 0 to 3. This is l1u du. This is l0u du. So finding out this properly, we get this term. Coming on to next, we get the solution as c03 is equals to 1 by 18 2u cube plus 6u minus 11u square by 2 minus u to the power 4 divided by 4 0 to 3. This is after integrating the above polynomial. We get this, and solving this, finally we get c03 will be equal to 1 by 8. Similarly, we will find c13 as 3 by 8 and c23 again as 3 by 8. Now we will find c33. c33 will be equal to 1 by 8. Putting in the values in the same formula, here this is L3U. So integrating this particular equation, we get C33 is equal to 1 by 8. By putting Ci3, that is C03, C13, C23 and C33 in the equation 1, we get integration of f of x dx a to a plus 3h will be equal to 3h upon 8 y0 plus 3y1 plus 3y2 plus y3. This is the Simpson's 3 by 8 rule. Thank you.